All right, welcome to the first session of mathematics, grade 11. And the topic is called the exponents and surds. But most definitely, we're going to start with the first basics at which this mathematics starts. So now here we have some few important notes that we need to really take into consideration. Here we are going to talk about the rational exponents. So now when you talk about the rational exponents, we are talking about the exponents that are really rational, right? The rational numbers are numbers that we know that they actually terminate, but irrational numbers, most of the times we know that those are numbers that do not terminate. And then again, the laws of integral exponents apply to rational numbers. So what we see over here, these are laws of exponents, and I believe we are all familiar with these laws of exponents. There are 5 of them, and then we also have the definitions of the exponents. Now, when we have a look at the laws of exponents, we have law number 1, whereby we multiply the same basis and then we add the exponents. And in law number 2, when we divide the same basis, we're going to have to subtract the exponents. I'm not going to dwell too much on this because now this is grade 11 and you need to know these things. What I'm doing right here is just a reminder on how these laws actually work. And then we have the rise to power, which is law number 3. We can see that our base, it is enclosed inside of the bracket and it has its exponent. But our base, since well, it is enclosed in the bracket, we have power, which is outside of the bracket. So in this case, we know that this law, we're going to have to multiply the exponent and the power, which is outside of the bracket. And therefore, our final answer will be a to the power of n multiplied by m. And then law number 4, it says to us, it is the same as this law, but you need to understand that when we have two bases which are different, and these two bases are multiplied together, and they're enclosed inside of bracket, and then we can see that outside of our bracket, we have the exponent. We can simply distribute this exponent by applying law number 3. We can simply distribute this exponent to each and every base by doing multiplication. And then law number 5, it is the same as law number 3. But you need to understand that law number 4, it goes hand in hand with law number 1, because at the end of the day, you are multiplying the exponents. But be cautious and be understanding. You are multiplying the bases, which are not the same, but we know that on law number 1, we were multiplying the bases, which are the same, hence why we added the exponents. Do not add the exponents in this case. And therefore, law number 5 is the same as law number 3, where we're going to have to distribute our exponent, which is outside of the bracket, inside of the basis inside of the bracket. We just do the multiplication, just like we did on law number 3. And again, law number 5, it seems as if it goes hand in hand with law number 2, whereby when we divide the same basis, we subtract the exponents. But we can see that here, it is true, we are dividing the bases, but now these bases are not the same. In this case, we really cannot subtract their exponents. And be careful, know how to move from multiplying to this answer whereby we just added the exponents. At the same time, know how to move from this expression backwards, applying laws of exponents. We really do not just focus on applying laws of exponents, moving only in one direction. Again, by just looking at this, be able to decompose this into two bases, whereby you separate the exponents. Same applies to all of these laws that we have just dealt with. And then the definitions of laws of exponents, these are not the laws, these are called the definitions of laws of exponents. We know that when you multiply the same basis to the nth term, we don't know how many terms, could be 4,000 whatever terms. But in order for us to represent this, we can write it as a to the power of n, because we don't know this n, it stands for how many number of terms. And then definition number 2, it is the one that we should know, and it's popular, that anything to the power of 0, it will give you 1. But make sure that your a may never be equals to 0, because we don't have a thing such as 0 to the power of 0. When you go to your calculator and try to prove that, you can just punch 0 to the power of 0, you'll see that you'll get your math error. So in this case, a may never be equals to 0. And then now we move to definition number 3, where it says a to the power of negative exponent. Now, a to the power of negative exponent can be rewritten in a form of a fraction, but immediately when we write a to the power of negative exponent, you need to understand that our a to the power of negative exponent will turn into a to the power of positive exponent, where we're going to take the reciprocal of this expression over there. And note that our n is the element of the integers, okay? The element of integers, and a may never be equals to 0 once more again. Now, definition number 4, be able to flip this back, basically, okay? When you have a negative exponent at the bottom of your fraction, and then when you take it at the top of your fraction, your exponent will most definitely change its sign. It will change from negative to positive. In this case, we're going to have a to the power of n. And then definition number 5, it's more or less of saying interchanging the numerator and the denominator. Basically, here we are talking about the reciprocals, but you have to understand that when a goes at the bottom, because here we have a to the power of negative m, but now when the a goes to the bottom, we're gonna have to change the sign of the exponent of a. Now it's gonna be positive. Same applies to b to the power of negative n. When we take b to the power of negative n at the top of the fraction, therefore the exponent of b will most definitely change its sign, in this case from negative to positive. And I hope these definitions are clear. Now, this is what we also need to know. Let me rewrite this because it seems as if it's not clear. So we have expression that looks like this. If we have a root of, let me try to fix that so that I present it properly. So if we have a root of a, if we have nth root of a to the power of m, you need to understand that this expression can be rewritten in the following way. So now a, we still have to the power of m, right? But you need to understand that this root sign, as we represent it in a form of exponent, we're going to have to take 1 over this. So that means here we have a to the power of m. Let me enclose this inside of the bracket. And then I'm going to take my root and represent it as an exponent, meaning it's going to be 1 over n. So this exponent of a to the power of m, which is 1 over m, can be written back in this form. But if you want to convert this form to that form, just know that root nth root in a form of exponent can be written as 1 over n. And therefore now we can end up by applying law number 3, which is raised to power. We're gonna multiply our exponent within the bracket. So that means we're gonna have a to the power of n over n as our exponent of this base, which is a, okay? So these are most definitely the most important basics that you need moving forward with your mathematics until I don't know, until you do maths for the rest of your life. This is what you probably need. So because we are under the exponents and all of those things, and there are points whereby we're going to have to simplify and do all of those things. So now, here we have the golden tips on how to actually simplify these algebraic expressions that will be provided to you. So now, simplifying exponential expressions. This is what we're gonna do now. If this is the first golden tip that you need to take into consideration, if the bases are numeric, write the basis as the product of prime numbers. So let me try to make an example of what It is actually been said over here. So our bases could be in a form of alphabets or variables per se. For example, I can have my base as A, I can have my base as X, I can have my base as B. That's not numeric. But if my bases are numeric, for example, I have 4 to the power of 1. So now when I have 4 to the power of 1, this is what I'm going to do when I do simplification of exponential expressions. Because I have to the power of 1, I'm going to change this base of 4 to the power of 1. This is not a prime number because it has 2, it has 2 and it has 2 and 2, it has 4 and 1. So remember, a prime number is a number that has only 2 factors, which is that number and 1, right? So that means we're gonna have to change this base. We're gonna have to change this base into because it's numeric, right? We're gonna change it to a prime number. So now how are we going to change this base to a prime number? So we know that 4 can be presented as 2 multiplied by 2. That's the first thing that we know, right? We know that 4 can be presented as 2 multiplied by 2, right? That's the first thing. But we know that one of the laws of exponents is that when we multiply the bases, we add their exponents. So that means this is going to be the same as 2, and then we're going to add the exponents. It's going to be 2 to the power of 2. So that means 4 or 4 to the power of 1 will correspond with 2 to the power of 2. What we did is we changed this base of 4 to a prime number. So now our prime number in this case is 2 because what are the factors of 2? Is 2 and 1. So a prime number is a number that has 2 factors, which is that number and 1. So that means we managed to change this 4 into prime number. So if your base are given in numerical, So now golden tip number 2, it says to us, remember to use brackets for the base where necessary. That's very important. Remember to use brackets for the base where necessary. Okay. You will see through the entire problem solving. What do we mean when we say this? And therefore, golden tip number 3, it says to us, change surd form or roots to exponential form. What I did over here, when I wanted to show you why they say this expression, it is the same as that, it's because I had to change my surd or my root into exponential form. In this case, we managed to change this root into exponential form, in this case, which is 1 over n. Initially, it was nth root of a to the power of n. And then we change it into exponential form, which is 1 over n. And therefore, golden tip number 4, it says collect using laws of exponents. Collect using laws of exponents. So collect meaning referring to the same basis. For example, if you have an expression that has the same basis, collect them. Whether you are dividing the same basis, whether you are multiplying the same basis, collect using laws of exponents, because you know that when you multiply the same basis, what you're gonna do with the exponents, you're gonna add them. But when we divide the same basis, we know what we're gonna do with the exponents. We're gonna have to subtract them. And therefore, write the final answer with positive exponents all the times. So if it happens that the final answer it is presented in a negative exponent, we actually really do not want that. So that means we need to express that in a negative exponent. And then now meet me to the next video where I will be solving questions or simplifying exponential expressions.